Hello, hi, it's Alex from Blue Lightning Software once again. I just want to do a bit more of an example of, a test of what I was looking at in the last stream, which is the, what are they called? Can I remember the pointers, the pointers, function pointers. That's right. Here we go. It's the function pointers again. I don't know why this won't load. Come on. It's jammed. Sorry about the delay. Trying to open the. Maybe I can explain what I was going to look at. It's the function pointers. So we've stopped using a job because we're on stuff that would block the main thread. We don't have an opportunity to thread it because we want it to happen at the same time. We're not going to wait long enough to create the threads on the job. So rather, the job's overhead of a job system job seems to block it quite a bit. So we started using these pointers to functions, function pointers. What I wanted to look at was there's a few things, kind of more like this is the test we did last time. Just adding a vector. What I wanted to do was look at some other stuff. Now what you have are these functions, okay? So z out vector equals you could cross these, for instance, something like this kind of vector plus. What I want to look at, that for instance is possible. And can you see that we pass float 3's in there? All float 3's, but we use vector 3 cross. Like this, loosely vector 3 cross. It's very similar to math cross. Is actually decompiles. Is that a decompile in this case? I'm not 100% sure even. That's a method implementation. I don't think that's C#. I think this stuff is under the hood, but it seems to go straight to it. So maybe it's like vector 3 decompiled. What I wanted to check is if there is any difference. So I've got it over a set of iterations. I guess what I could do is create a very similar one. Actually, we could and then in this one do math dots cross. Yeah. Now and then create where did I create these in the tests? I'm not even sure which is better. Whoops. Invoke 2 equals position delegate to position change math. Let's make that clearer. Just to see if there is any difference between those two. So where I've got the buttons triggering it, this is the, I think, oh yeah, it was overwritten single job test. So this is actually now a function pointer test. Oh, that seems like a waste of duplicated code, but it doesn't matter. Hopefully it's clear. So we've got this, and we've got this function point math. All right, and the buttons stop making sense. Index 0. Yeah, it does noughts the top one, which makes sense when you see the screen. So nothing is naught, which is it's function pointer test math. So math is now nothing, and jobs is not math library. And I just want to see if there's any change at all in these. So is there any difference between these? You know, people have said not really. Actually, I think is possibly the answer, but I just want to check. They seem to have the same output. Yeah, invoke test. Oh gosh, which is the higher one? It's going to be back to front. I know. See, it's just a mess now. This whole scratchpad thing. Whoops. Should have names like naught text and one text, that kind of thing. Doesn't matter. We've got different ones. I'll change them out if it's wrong. Maybe need a few more cubes or iterations because they're so quick. And once you start these iterating, because these are the burst compile, they're just gonna be like, so we'll give it 10,000, 30 milliseconds, 30 milliseconds. There's no difference. So not that I can tell with this number of iterations. Yeah, they look like the same thing. So I think maybe, I mean, they're both inside function pointers, but returning to what was different. This one's using vector 3 cross, and this one is using a math cross. And interestingly, do you know, I actually found that I was thinking that these, maybe it's just not the case. A cross isn't too bad. Alright, so they're almost exactly the same, because this is like using the math implementation of cross for the math lib, which is slightly different. You see it's written there. That is the math method decompiled, math decompiled here. Vector 3 math, it's slightly different, just the way it's written, but they're apparently exactly the same, which is interesting in terms of the time. The other one I wanted to look at, so we do vector normalize. Makes this vector have, cannot convert to O. Now, I'm not even sure how this would be working, if it's asking for a cast or what. Or it's saying this cannot normalize. What does it say? Normalize doesn't have brackets, does it? No. I think I wanted little n. No, I think I'm going crazy. What's going on? It's normalised. That's it, isn't it? It's not big N. Doll. So this may have worked. I think it was just me struggling to get that done. So I'm getting used to the new mathlib normalise, which is like this. That would be math dot normalise bracket math dot cross close brackets. Can you see the normalise wrapping that? This one at the end. Return normalise this. See that check there, right? This is an annoying thing about mathlib. This check exists, otherwise it returns 0. Okay, so that prevents divide by zeros. This one doesn't. You see square root dot, this one. It looks almost completely different. I mean, it's not. It's weird way. See, it's weird how they do this. Like magnitude value. Blah blah blah. I mean, I'm not great at vector math, but this one's using square root dot. It's very similar. Just squaring it all out. Square root of dot. Math square root of dot. Essentially, yeah. Okay, but that one had a. The vector 3 one had a null check, not null check. Sorry, it had a this thing. If number is greater than very low 0.00001 kind of thing. That one has a 0 check. So. I mean, we're not even checking the results, but to make it fair, I would actually have to, because I've wound up having to do this, is that you need to 0 test before the normalise, technically. So this is taking that cross and normalising it. And is there any difference? I mean, mathlib has got the edge on a technical level because it's not doing the 0 test. So I'll try it with a 0 test after this. Yeah, so it's got it's really, it's like logically, it's not massively quicker, is it? It's not aggressively bursting faster. I mean, these are quicker than it would be if you did these without burst compile. Do you see what I mean? Whoops. So it doesn't matter. The mathlib. Alright, what did I have to do? I won't have it in this project. I mean, it's almost like saying... Keep one of the variables. No, we can't. In out. A bit sleepy here. This thing's going on. It's kind of like saying output. Is that 5 zeros or yeah? then the magnitude in that one. It was, did it say the magnitude? Yeah, I wouldn't bother doing that. I'll just do the output dot equals. That seems to work. Yeah. That makes total sense. All that level the time. So we're saying that it's just like the lack of zero checks is. It's an interesting thought if you're looking at some of the stuff and doing a load of functions with lots of this. Is it worth converting to mathematics.lib? I mean, it's supposed to be. Did I actually re-import that? I've gone crazy again. Start re-importing every 3 minutes. But is it worth converting everything? If you've got some code that is all like vector3 cross, it does a naught check for you. I wrote some functions in some other stuff I was doing where I kind of wrapped these up, these zero checks before, like I've got normalized with zero check function, that kind of thing. So I don't know if these are better in jobs. Like it could be like the math lib. There is stuff along the lines of the math lib could come to its own if it's more simmed. It's more geared towards parallel jobs, if that makes sense. I mean, reasonably, that's a tiny bit quicker, I think. Every time, yeah. I mean, that would almost be accounted for not using the magnitude. They seem the same in this, actually. I think if you're not parallel processing, I don't think it matters. I think there are arguments that this math lib is better in parallel processing, particularly a sim structure. And, don't quote me on that. I may be wrong, but that's possible. They look very similar. I'm not sure what else I wanted to test. The other thing is these are vector 3s in, so it's got vector 3 conversions is another thing. A lot of code, like say I'm just taking functions, right? In this other one that I am doing, I'm not even converting any of this unless I have to, unless it makes me convert the float 3s out, because it doesn't like float 3 the vector conversion the way it works. Apart from that, I think that's what I wanted to test in this stream, so I'll probably wrap it up. But is just that no, these seem to function very similarly actually when inside this not threaded, not parallel simmed. It's not running through arrays like a parallel 4 job, which would be a different test possibly and probably just read about it. But no, they look very similar actually, the vector and the mathlib in this function pointer scenario. So I've tried it here. I guess the other one was actually, while I'm here, what I did want to test is how much of this kind of math nothing test. I'll revert back to the nothing test. I'll stick with the function pointer math. No, I'll do the nothing test here. Just because then it will line up. So I did out vector, and then I did stuff like, because I've got kind of ton of stuff doing this. So what I'm looking at, I'm just interested to know how many of these. I guess doing it once if you're going to repeat it. Out vector is then of itself. Alright, so I've put 2 of these in there. And the cross and normalize seems good. It's got the dot in there. I think they don't call it a dot so much. What's that saying? You can't normalize a dot. Does a dot output a float? Whoops. Out vector equals vecin, and then just, I'm just messing around with some math. Times x. Okay, that's a bit of math. And then I'll put this into the nothing vector, which I think is complexio. Not in the job, just regular complexio. Oh. It's interesting. We get some really weird results. I didn't actually notice what was happening to the cubes. Where did the cubes go? That's the interesting one. The cube's going into some warped inner space. They would have if you didn't do the zero check on some of the math stuff. They would get all NaN and all kinds of stuff. Oh, this is weird because I'm doing more like that at the top piece. It shouldn't matter because I've stored out vector. I had to declare out vector as being different to vector in, whereas here I'm using it. I'm not sure if you saw that. If it's obviously not obvious. Yeah, that'll be the same. Okay. So let's plug that in. And what I'm trying to see here is nothing is like not using these function pointers. How much math like this do I need to make these break even, kind of thing? Is just tests that I want to run before I kind of apply it to anything else that I'm doing. Is there an obvious 6 milliseconds? Oh wow, that's working on 1,000. Oh, it would do. More cubes. 1368. Nine and 13, 10 times. It's interesting actually. I think at this level, 8 and 6, it's almost like it's close to break even, possibly at 2, let's say. 8 and 7. That's really interesting. 3 times. That's interesting for me because I'm just thinking 3 or 4. I think we're saying that 4. This number could be anything, couldn't it? 4, 6, 6, 7, 8. Yeah, I think by the time you've done 4, also is there an element of the compilation? Did you notice that? All right, the first one's 8, second one's 7, 6 every time, and then it's 6. There is an element of the burst compile. So even at 3 times, if you play it a few times, the first time it's probably to do with the burst compilation. That's the burst gets quicker. Alright, it's breaking even, I'd say, then at 2. I'm not sure about 1 now. It goes down to 6, but 5 or 6, yeah. It's not. It's a really interesting conclusion from my point of view. Is that doing this amount of math? Alright, so across a dot, and then multiply a vector by that dot. Product. That's it. You know, that's. Do that twice, okay, and you're better off with a function pointer in the editor without compiling it. This thing helps it do il2cpp. I could test this. I probably will actually. I'll build it, and we can look at an il2cpp of the pair of them. Okay, so I just want to make it do some more stuff. Well, I mean, the argument is that if I did this with the mathlib compiled, would it make a difference? Because I think I was very quickly as to the use of the mathlib and float 3s, we are using float 3, but we're putting them into the vector 3 library. And let's multiply it by itself again. Subtract vector in for good measure. Because these are the kind of functions that I'd be converting at the moment. Something very similar to that. Looks weird enough. Where's complexion? What was it? This position came in. Was that really? I think that's where it switched, yeah. Oh no, I've lost the plot because I think that doesn't make position there. No. Got position X, then I've lost position X. Oh wow, I've gone crazy. Float out vector. I think I just made everything out vector. out vector, which in this case is position x. How then does it have vector in? Oh yeah, position would be vector in at this point. That's right. And then we can make position. Yeah, that makes sense. Is that an exact duplicate? No. No, it's not. It's position equals position times x, and then yep. I know we could do that times equal here because it's slightly different positions, being like the in vector, and position x is kind of dealing with it. Okay, but those two are equivalent. It's a bit fiddly. Just check they work and then do a build of it. See what's going on in il2cpp. It's quite long running. Oh, this is interesting. This suddenly got yeah, wow. Oh, of course, sorry. Why is this? Oh my gosh. Because we need to be much closer to the bone here. Yeah, whoops. Yeah, I think we did that once. It's kind of weird because it's so close to what I'm looking at. If you do that one time, it's just about worth. Yeah, by the time you've got it to there like twice the original, seems pretty static. That's the kind of minimum amount of work that makes it worth using one of these function pointers. And okay, I'll build it just to have a look. I'm pretty sure that this is set to do mono. Where we go? It's on the other screen. Mono. Should be il2cpp we're looking for. Gone stupid again. I can't find it. Where's il2cpp? Mine's always set to il2cpp. I can't find il2cpp on the player. Other settings, it'll be here somewhere. That thing. You don't even have a choice somehow. Is that because of that attribute? You no longer have a choice. Wow, that's interesting. It didn't give a choice. Can I just test something whilst we're here? Before I do this, I'm just going to put the whole thing. I'm massively tired, I think. I want to do this into mathlib. Oh, we did the cross, and then we did the dot. That's what we want. So we're possibly with these. I think dots are alright. I think everything's there. Maybe project on a plane. Do you know what? This is a weird one. Okay. I wasn't even sure if math dot project. Oh no, they're gonna realise I don't understand math. Food. Alright, it's pretty easy to read the code. So we've got project on plane. I think that's saying if that number is too small, don't do anything. And it's probably bored people to death with this. Project. You think it'd be underneath so we can see what's different. Okay, vector on normal, on normal, on normal, vector plane normal. Plane normal, plane normal, on normal. It's exactly the same check. Return 0, return vector. That is possibly the only difference. Vector, no it's not, because that's vector and that's on normal. There's a few differences. And return 0, it returns the vector. Plane normal. Number equals vector, plane normal. So number 2, number and number 2 are exactly the same, but then you come to this, which is different. Yeah, this is quite radically different, is it? Just number 2 over num times vector 2 minus, that's for x, vector 3, vector y, minus plane normal, dot y, times number 2 times the same thing. It's got this thing all the way through it. Do you know, right? Alright, call me stupid, but I can't write on these. You only need to calculate that once. That division, and multiply the vector by it would technically be the same thing. Well, let's just make that plane. Let's make that project. There's such a similar fact. It's probably this time-wise be the same. Okay. Then I'll do one quick test. Is a nothing test. Function pointer 2 test, we call it. Kind of beefed it up so there's a bit more. I think this makes no difference to, alright, what would make a difference? See, we made it vector 3 as well. Vector 3, out vector vec. And then at the end we converted to that. So it's also, I think this makes virtually no difference. I think someone proved somewhere that these actually compile to almost I think actually the exact same thing. Alright, so maybe a complete waste of time, but these maths things are definitely different, and these are less safe. The math ones, they all need a zero check really, so potentially they're only quicker because of that, but I just want to see if it can make it a tiny bit quicker. So it's doing a bit more math now. Just to see if there's any difference. Oops. I mean, it's like maths is pulling ahead, yeah. I think it's a bit erratic. No, it's the same. Once it's compiled, I think they're the same. That one, still, whatever you do, there's nothing in those functions in MathLib. It's like I say, if there's anything, it's to do with jobs and parallel processing. So, okay, we'll forget about that. We'll go back to it. Don't be silly. Make this a nothing test again. And compile it. Okay, I'm just going to find the folder. Let's look for the folder on my thing. Project. My project. Really interesting, this. I'm only going to do an il2cpp build. This versus nothing, and then we can... Oh, what's up with that? It's failing the build. Oh wow, is this unbuildable nonsense? What? Oh man, I get this sometimes. The first time I build something, it's to do with the Unity version, I think. It starts trying to add spurious usings to the thing, to my code. Okay, let's go one more time, save it. Build it. It's gone midnight now, so a little bit bored, tired, but you know, it's interesting stuff. It is demonstrating that this amount of work is around the break even. If it's doing more than that, and you can do it, you don't even need to convert to this. I could put float 3s in this. I only did this to be annoying. It doesn't matter if that was a float 3, we never passed it back. The float 3s and the vector 3 math, these are a lot safer than math. I prefer using these if I can, because they've all got a zero check, and unless you plan to do parallel processing and read about it, if even then, these are totally usable. This old vector 3 project, I wouldn't force myself to convert to math looking at the results here. It'll be another one for the il2cpp test that we're running now. I can't believe it takes time to compile just that. You know, over a minute to compile what's got nothing going on in it. But yeah, I mean, you can look more at the conclusion, and the bit that I'm kind of pulling out and replacing does this like maybe 3 times. it's not a massive edge, is it? It's like, but then I was looking at 10,000. So, okay, if you got 10, and this is kind of the scenario in what I'm working on. You got 10, if you had 1,000, say there were NPCs or something, and this was part of their movement. If you do it as all as function pointers, you're doing at least this amount of math 3 times, then yeah, you could be saving milliseconds, which is going to lead to frame rate, maybe if you're lucky. You know, it's not complete madness. I don't know that it was sharp. I mean, yeah, per frame. So we're going to get a per frame number. All right, this just compiled. This is il2cpp build. So we're going to give it 10,000 cubes with 10 jobs. I don't think it can have a compile thing there unless it did. Wow, do you know what? Yeah, il2cpp burst in the editor gave us something much more like il2cp. This is interesting. This kind of defuncts it. Yeah, once compiled to il2cpp, is doing quite a bit of what burst is doing actually in the editor. Yeah, burst is compiling it to a burst compile, a C++ native kind of source. They call it like HPC. I've seen some weird stuff, high performance C#, but it's not. I think that's more il2cpp is more like high performance C#, although technically a kind of C++ native again. I think both for compiling it to kind of native. So this is il2cpp compile. All right, so even, do you see that? Even in a build, the first compile, the first time you click, doesn't actually even make sense. But the first time it runs it, see, first time's always higher. Just the first click on this when it says jobs, it means the function pointers. Wow, because this is internal. Do you know what? Because like with the overhead, have a look at this. il2cpp is very similar on 1. More so than the use of the il2cpp compile is getting you way closer to it, even with a lot of work going on. 4 times that. Let's expand out. Wow. It's nowhere near as apparent, is it, when you compile to il2cpp? So that's like a straight mono compiled to il2cpp. Yeah, just the main thread, no fancy function pointer or anything. Can you see the amount of iterations to really make it visible? It's made me wonder actually. 20 times. There's 20 times this stack of math within the whole function pointer to actually make it break even. I've kind of done it for something because it's way quicker than a job. Yeah, the overhead of a job, particularly if you're just doing it one time. But no, compared to il2cpp, yeah, like a non-threaded job, so the job system's not really working as such. It's like, it's just completing it immediately after schedule kind of job. So it's just running on the main thread and not using worker threads, which would be the case here. Wow, that's incredible. So thinking the il2cpp, you need a lot more going on. I would say around 10 times this within the same function call to make function pointers burst compile. In this instance, just the example I've done here, I did slow that down. Do you want me to mess around with it? Do you mind if I kind of, let's try the pure math variation. I'll try and desperately make that useful. Because I always compile everything to, let's try to delete that while it's running. I always compile everything to il2cpp anyway, so that's quite interesting. So it does it, at least it all works with let's try the mathlib compiled. I did the pointers, I've got the invoke pointer, it was the best kind of idea they had. Keep releasing the reference to this one. Function pointer invoke. It's all set up, it's proper invoke. It's about as quick as it does it. Okay. Just save it. It's a shame, isn't it? I mean, it's probably why this hasn't massively caught on. I mean, the benefits of the burst and the jobs only really becomes apparent when you multi-thread them. It's something I didn't really demonstrate hugely. I did look at it once or twice, I think, possibly in a different context of tasks or something versus jobs. But yeah, I mean, burst compile is obviously a million times, well, up to 5 or 10 times faster than just mono, standard Unity C# mono thread. But as we can see here, it's struggling to beat il2cpp massively into the ground until you do a lot. Oh right, do you know that one is broken? That's the mathlib not working, and the reason is the naught checks. Probably this that project on plane is the same complexity as a function. It's probably to do with this, because this didn't have a null check. Right, one of these came out with 0. I mean, what I wound up with was and then unfortunately it's not really testing it properly, because I could do it without the project. I think the other ones are fine, the other ones won't break anything. It isn't normalized as such. I'd have to really make it fair, I have to drop the normalization. Let's just double these, alright? Right, because the things that could fall over in the math library out of those few are the normalized and the project on the plane. Because if you've not done 0 checks, the mathlib doesn't contain 0 checks. So, I mean, just adding the just that amount of math in each now. Because it was kind of erroring, essentially. Like, what I found with these is using that math, if you don't do zero checks on the things that could have division by 0, you're going to get a load of null check, NaN, a load of NaN without testing for 0 vectors. It's not the most succinct videos, are they? They're kind of boring, long-winded kind of thing. It's really looking at it. It's because it's late at night. I'm just dawdling through it. I'll tidy it up. I don't know how I'm taking an hour doing this, but here we go. It's worth looking at because now we know that il2cpp compile of this kind of stuff. It needs a lot more going on inside the function that's being called before you can definitely say, oh wow, yeah, it's outperforming. Okay, they work now. They still don't work. It's still broken. Oh no. Oh, it possibly wasn't even broken. It possibly was breaking, but it's just giving us a NaN. And God knows where those cubes wound up. Alright. Oh gosh. Let's rewind some stuff. Go. So we just put the projection back. I think that was it. And actually that one doesn't normalize at the top. But what went wrong was they both wrote to the same line. The task test. So the function pointer test math. Now it goes to the bottom text. It wasn't erroring quietly as it might look like at one point. There's a lot of things that honestly this mathlib, the results, you got to be really careful. The stuff I've had coming out is just a lot of NaN to do with anything with like division or the square roots or whatever. If you put a 0 vector in, it kind of quietly comes out with a NaN. So this is definitive. I mean, it was looking like 10 times, wasn't it? I can't remember now, 5 or 10 times using just normal vectors. I don't think this actually is at all different once you've compiled it. The mathlib is a very vague advantage over the vector 3 libraries. Depending on the amount of work, there's going to be a tiny bit of overhead. And it's probably just different implementation, and actually that the 0 yeah, okay, it's not going crazy. It's just flicking in and out. It's doing some weird cross and bringing them back, time and space back to where they were. Yeah, I mean it's the same result. 5. Yeah, 5 times that amount of math. It's almost indistinguishable at 5 times. 10 times it breaks even. 20 times. 5 or 6. 6. 50 times. Wow, that's incredible. So there we go. Until you do like 50 times that amount of math. Yeah, if you're doing something that did that like 50 times, it would 10,000 times in a frame, barely breaking even at this. That's when you would start making games that would affect your frame rate. That because that's il2cpp versus these function pointers. So yeah, if you have a massive, that's probably better than a job inline. If it's doing that 10 times that within the same function. See, it's put me off doing what I was looking at doing because it's maybe like 10 times that. Quite a solid 4 point, maybe 5, and that's more 5. Yeah, I mean it's margin if it was doing that 10 times in a function. I'm probably labouring the point now. Hopefully that makes sense to everyone. So thanks for watching.